Hello everyone, I'm going to show you how the OS perform dynamic partitioning placement algorithm. By using dynamic partitioning to manage the memory, the OS have to decide which algorithm to use to select an empty block to allocate to a process. Each of the algorithm is limited to blocks that are bigger than the new process. The first algorithm is best fit algorithm. This algorithm will choose the block closest in size to the request. It is the worst performer compared to another algorithm. Since the smallest block is found for process, the smallest amount of fragmentation is left. The memory compaction must be done more often. The second algorithm is first fit algorithm. In this algorithm, it scans the memory from the beginning and chooses the first available block that is large enough. This algorithm is the fastest algorithm. Now, let's look at the heap memory management scheme. This rectangle is the main memory. U is the memory block that are used. And H is whole. The empty block in the memory. If we see the whole is arranged accordingly, we can combine it and become one whole. Then it will become like this. This number is the size of the block in the memory. Now, list out all the size of the whole for reference when doing the algorithm. So, we minus the behind size with the in front size. Then, we get the size of the whole. Now we see the process request table. The process with the smallest number will have the priority to allocate in memory. Now we have all the information. We can start to do the best fit algorithm. Start with process 1. The size is 55 kilobyte. It needs to find the whole size that is closest to 55 kilobyte. The first whole is 20 kilobyte. The second whole is 145 kilobyte. And the third whole is 205 kilobyte. So, which whole size is closest to 55 kilobyte? The second whole. So, we place process 1 to the whole. After the placement, process 1 has used up the space. The whole size will become smaller. So, we minus 145 kilobyte with 55 kilobyte. Then, equals to 90 kilobyte. So, the whole has 90 kilobyte left. After that, we need to update the size of the memory below. (135 kilobyte). So how we get this number? We add 80 kilobyte with the process size 55 kilobyte. Then it will be 135 kilobyte. Now we allocate process 2. the size is 40 kilobyte. So we see which hole is closest to 40 kilobyte. The hole with 90 kilobyte is closest to 40 kilobyte. So we place process 2 to the hole. Process 2 has used up the space. So 90 kilobyte minus 40 kilobyte. This hole has 50 kilobyte left. Then we update the size of the memory. 135 plus 40. So 175 kilobyte will be here. Process 3. The size is 30 kilobyte. As usual, find the hole that is closest. So we fit it into 50 kilobyte holes. Then 55 kilobyte minus 30 kilobyte equals to 20 kilobyte. So this hole has 20 kilobyte left. Update the size of the memory. 175 kilobyte plus 30 kilobyte equals to 205 kilobyte. Now process 4. The size is 100. So we fit it into a hole that has 205 kilobyte, as 205 is the closest one. Process 4 now has used up the space. So 205 kilobyte minus 100 kilobyte equals to 105 kilobyte. The hole now has 105 kilobyte left. Update the size of the memory. 365 kilobyte plus 100 kilobyte equals to 465 kilobyte. Now we move to the last process, that is process 5. The size is 20 kilobyte. The best hole to fit in process 5 is this hole, 20 kilobyte. After fit in, no space anymore for the hole. Now, no more process requests. We label out all the information. That's all for best fit algorithm. Now, let's start to do the first fit algorithm. The first step is to combine each of the holes that are arranged accordingly. Then, label out all the size of the hole. By referring the process request table, we allocate process 1. The size of process 1 is 90 kilobyte. In first fit algorithm, we need to find the first available hole that is large enough. 85 kilobyte hole is the first available, but it is not large enough. So we see the next hole, 140 kilobyte. This hole is large enough, so we fit P1 into this hole. P1 has used up the space, so the hole will become smaller. Then we minus 140 kilobyte with the process 1 that has size of 90 kilobyte. Now the hole has 50 kilobyte left. Then we update the memory size below. 240 plus 90 equals to 330. So the size here will be 330 kilobyte. Now we allocate process 2. The size is 45 kilobyte. Do the same thing with process 1. Find the first available block that is large enough. So we feed process 2 into the hole that has 85 kilobyte. After the placement, process 2 has used up the space. So 85 minus 45 equals to 40. The hole now has 40 kilobyte left. Then update the memory size below. 40 plus 45 equals to 85. The size here will be 85 kilobyte. Process 3. The size is 55 kilobyte. We search for the first available hole that is large enough. 40 kilobyte is not large enough. 50 kilobyte is also not large enough. So we fit it into this hole that with 110 kilobyte. Now process 3 has used up the space. 110 kilobyte minus 55 kilobyte equals to 55 kilobyte. 55 kilobyte left for this hole. Update the memory size. 460 plus 55 equals to 515 kilobyte. The size here will be 515 kilobyte. Now we allocate process 4. The size is 55 kilobyte. So we fit it into the hole that has 55 kilobyte. So 55 minus 55 equals to 0. The hole now has no more space. The hole has fully allocated by the process. Now we allocate process 5. The size is 70 kilobyte. So we fit it into the last hole with size of 175 kilobyte. P5 has used up the space. So 175 kilobyte minus 70 kilobyte equals to 105 kilobyte. So this hole has 105 kilobyte left. We update the memory size. 625 kilobyte plus 70 kilobyte equals to 695 kilobyte. So the size here will be 695 kilobyte. Now, no more process requests. We label out all of the information. That's all for first fit algorithm.